Buildings are the primary cause of the release of greenhouse gases into the atmosphere. Approximately half of all greenhouse gases are the result of generating the power used for heating, cooling, and lighting buildings. The greatest potential reduction in building power usage is from increased building efficiency. To better understand the current performance levels of a building and how best to improve a building's performance, real-time floor plan dashboards have been used for some time. They show the current operation and environmental conditions in the building, and the building engineer can set alarms to be triggered if sensor values go out of range. While these systems properly monitor the equipment in the building, they have not generally contributed to improved building performance. Going beyond current graphical or floor plan dashboards, we examine advanced 3D real-time sensor network visualizations as part of a building debugging tool to help improve building efficiency. The input to this tool would start with a building information model that describes the building in sufficient detail so that the user can see and understand complicated, potentially conflicting interrelated factors, such as the relationship between a large window, a baseboard heater, and a cooling vent on the ceiling. In 3D, these relationships are readily apparent. In addition to the existing mechanical sensors, we include the monitoring of exterior building conditions with a weather station and interior occupant conditions with workstation sensors. To display the real-time building behavior and usage, we first render the building geometry with ambient occlusion shading to visualize the 3D space for the building, and over which other visualizations may be layered. By averaging a number of sensor values collected from neighboring cubicles, we can visualize properties such as daylight or temperature by simply recoloring the vertices in the geometry of a 3D model. Using a motion detector, we can convey occupancy of a cubicle by highlighting the silhouette of an object, like a chair, or by recoloring it. Occupancy of a space could also be visualized by adding transient geometry to the scene, like these position pegs that indicate presence. Transient geometry can also be used to visualize airflow scenarios, like heat coming from a computer under a desk. Larger temperature trends may be better shown using vertex coloring. For textual information, local heads-up display panels can be transiently shown indicating, for example, power usage for a space or even for a single outlet. Ultimately, a BIM-based building dashboard could help facilities and operations people improve the performance of the building that they manage. For architects, a 3D dashboard could help building designers to optimize their designs by visualizing simulation data instead of live sensor data. By measuring and visualizing building performance, we can better understand the complex interactions involved in building efficiency. Furthermore, improving efficiency will reduce costs, reduce greenhouse gas production, and will increase occupant comfort.